Hi, I'm Kuba, and today I will show how to fetch features faster. Another issue that we encounter when building mlops process is feature serving. A historical feature store is used during model training to fetch a large range of entities and a large datasets with small number of queries. For this process, the data fetch latency is important but not critical. On the other hand, when we serve the model features, fetching latency is crucial and determines prediction time. That's why we use the very fast online stores like Redis or DynamoDB. The question which appears at this point is, shall we call online store directly or use feature server? Because multiple models can use already prepared features, we don't want to add feature store dependencies to the models. Thus we abstract an online store with a feature server, which serves features using, for example, REST API. On the other hand, latency due to additional layer should be minimized. Using Feast, we can manage features lifecycle and we can serve features using built-in feature server implemented in Python, Java or Go. According to the provided benchmark, Feast feature server is very fast. But can we go faster with the smaller number of computing resources? To answer this question, I have implemented feature server using Rust, which is known for its speed and safety. One of the basic assumptions was to ensure full compatibility with Feast and usage simplicity. I have also decided to start implementation with Redis as an online store. Initial version is ready, thus we can start the benchmark. The whole benchmark code is available on GitHub. For simplicity, I will use Docker, thus in the first step, we'll prepare all required images, Feast and Yummy feature server, Vegeta attack load generator, and Redis. Then I will use data generator to prepare datasets, apply feature store and materialize it to Redis. Now we are ready to start the benchmark. In contrast to the Feast benchmark, where they used 16 feature store server instances, I will perform it with a single instance to simulate behavior on the smaller number of resources. The whole benchmark contains multiple scenarios like changing number of entities, number of features, or increasing number of requests per second. All results are available on GitHub, but here I will limit it to P99 response time analysis for different numbers of requests. All results were performed on my local machine with 6 CPU cores and 32 GB of memory. During these tests, I will fetch single entity with 50 features using feature service. For Rust implementation, P99 response times are stable and less than 4 milliseconds, going from 10 requests per second to 100 requests per second. For feast, following documentation, I have set go feature retrieval to true in featurestore YAML and additionally go option in feast serve command line. Thus I assume that Go implementation of feature server will be used. In this part, I have used the official feast dev feature server Docker image. For 10 requests per second, the P99 response time is 92 milliseconds. Unfortunately, for 20 requests per second and above, the P99 response time is above 5 seconds, which exceeds our timeout value. This benchmark indicates that Rust implementation is very promising because response times are small and stable. Additionally, the resource consumption is low. That's all for today. The whole code is available on GitHub. Please subscribe and thanks for watching. Bye!